We present Unpaired Learning for High Dynamic Range Image Tone Mapping by Yael Winker, Inbar Huberman, and Ranan Fatal. This research was conducted at the Hebrew University of Jerusalem, Israel. High dynamic range imaging allows us to capture a wide dynamic range using a camera by merging multiple exposures. However, conventional display devices such as LCD printouts and projectors have a limited dynamic range. Tone mapping is the process that reduces a high dynamic range image into low dynamic range, so that it can be displayed in conventional display devices. Existing tone mapping operators are typically divided into groups based on the way they process the image. Global operators, which are spatially invariant, treat each pixel independently. Local operators, which are spatially variant, apply different adaptation at different regions based on the local content. In recent years, learning-based operators have been proposed. Most of them are GAN-based. Existing GAN-based methods are trained conditionally. For that purpose, a paired dataset of HDR and the corresponding tone-mapped image is required. To obtain these pairs, existing work mainly use existing TMOs with high TMQI or human annotators to manually tone-map the input image. By contrast to these methods, we propose an unsupervised GAN-based approach for HDR tone mapping, without reference to any existing tone mapping algorithms. We define the distinct goal of producing LDR renditions that best reproduce the visual characteristic of native LDR images. We will now present our method. Given the input HDR image, the first stage is pre-processing. We estimate and apply an adaptive global curve compression to enable application and training over images arriving from the wild. The latter is fed to the tone mapping network N, as well as used to define the structure preservation loss. This loss is meant to keep the content of the input image unchanged, as well as to avoid mode collapsing during training. We derive this measure based on the Pearson correlation inside small image patches among different scales of the two images. The network is also trained to minimize an adversarial loss with respect to native LDR images. We train a discriminator network to distinguish between the tone-mapped image and the set of high-fidelity native LDR images. By training N to full D, its output acquires the desired appearance, avoiding common HDR TMO artifacts such as halos. The final output image is produced from the resulting luma and the chromaticity of the input image. We will now show some results of our method. On the bottom are some of the input exposures used to create the HDR frame. On top is our tone-mapped output image. The tone-mapped images produced by our method do not seem to suffer from visual artifacts and have an adequate amount of compression with no over and under exposure regions. Compared to other methods, our approach produces halo-free results. The local and global contrasts appear fairly balanced and consistent with ones found in contrast-rich native LDR images. To sum up, we presented a new approach to perform HDR tone mapping. In contrast to other GAN-based methods, our method does not require a dataset of paired images. We constrain naturalness by using GAN training with respect to native LDR images. We describe a dynamic range estimation procedure. Our results achieve a high level of compression while preserving local contrast, structural integrity, and natural appearance of this input. Thank you very much for listening, and please check out our GitHub repository for more details.